So now we're going to start looking at some special types of sequences, and one of the special types is called an arithmetic sequence, and this is the point of section 13.2. Arithmetic sequences involve adding or subtracting the same number over and over again. And let's look at an example here. Suppose we start with a given number, and I'm just picking 50 at random. And then we add the same number over and over again to get an infinite sequence. So let's just say that we add the number 4. The sequence that we get is 50, 54, 58, 62, 66, so on and so forth. Now, what am I doing here? I'm just taking 50, adding 4 to get 54. I'm adding 4 again to get 58. I'm adding 4 again to get 62, adding 4 again, adding 4 again. So the key here is that we keep adding the exact same number again over and over again. And this is what's called an arithmetic sequence. Now let's think about this example a little bit more. We can, using our sequence notation, a sub 1 is 50. A sub 2 is, the second term, is 50 plus 4 more. We added 4 to it. A sub 3 is going to be 50 plus 4 plus another 4, or 50 plus 2 times 4. That's just a way of thinking of that 58 that we got for the third term, right? And then A sub 4 is 50 plus 4 plus 4 plus another 4, adding a third 4 on there, or 50 plus 3 times 4. That's how we got our 62. And then if we add another 4 on, we'll get A sub 5, which we could describe as just 50 with 4 4s added on it, or 50 plus 4 times 4. That's our 66 term. And A sub 6 would be the next term. If we add another 4 on, it's like taking the original 50 and adding on 5 copies of 4, right? 5 times 4, which is 50 plus 20, or 70. And so we can actually turn this into a general formula for A sub n. We could just say we take that first term, 50, and we're going to add on that number 4 so many times. Now, the one thing is, the number of times we add on a 4 is always 1 less than the subscript on this term that we label here. We're labeling A sub 6. We actually had to add on 5 times 4 there. So we have to write n minus 1 times 4. So the number of times we add on 4 is actually 1 less than that subscript. And this is a general formula that we're going to work with. And let's move down to the box here at the bottom. If A1 and D represent any real number constants at all, any sequence of this form, A sub n equals A sub 1 plus n minus 1d, is called an arithmetic sequence. A sub 1 is the first term, just like the 50 in our example. That's the A sub 1. The D is called the common difference, and we'll talk a little bit about why we use the word difference as we go through more work, but the D is just the 4 that we used in our example. So way back when we started the example, 4 was the number we added on over and over again. We saw it here in these terms, and in that more general formula for A sub n, we see we're multiplying by 4 here, and that's what the D represents. And this n minus 1 is going to be the same no matter which arithmetic sequence we're working with, because you're always going to get the nth term by taking the first term and adding on n minus 1 copies of that constant D. So let's start doing some problems. And our first exercise here is determine if the sequence is arithmetic, and if it is, let's find the common difference. So we're just given a sequence 2.3, 3.1, 3.9, 4.7, 5.5, and what we got to, all we got to determine is there a single number that we can use to get from one term to the next over and over again. So we're really asking ourselves, like what can I add to 2.3 to get 3.1? And the way I would figure that out is, well, 2.3 plus what is 3.1? I would take 3.1 minus 2.3 to figure that out. 3.1 minus 2.3, I think, is 0.8. So we would add 0.8 onto 2.3. Now this subtraction we went through here, notice how we subtracted to get the number we add on. That's why that is called a common difference, because the number you add on is the difference, or the subtraction answer you get when you take one term minus the preceding term. Now we got to see if that pattern continues. So if we take 3.9 minus 3.1, we get 0.8. So again, we've got the same one there, but we got to check each one of these. 4.7 minus 3.9, that's 0.8, so I'm adding 0.8 on again. And finally, 5.5 minus 4.7, that's 0.8 again. So sure enough, at least in the terms we see and so far in this pattern, we get from one term to the next by adding on 0.8. So the answer is, yes, this is an arithmetic sequence. The common difference D is equal to 0.8. That's really all they're asking us for. They didn't ask us for the general formula, but let's go ahead and write that down. So I'm going to use this general formula from the preceding page. So that the nth term of this sequence can be described as the first term plus n minus 1 times the common difference. So in this example, we have a sub n is equal to 2.3, that was my first term, plus n minus 1 times the common difference is 0.8. So when you recognize that you have an arithmetic sequence, there's this handy-dandy formula we can use to describe the sequence in general. Okay, that's exercise 1. Let's go ahead to exercise 2. Determine if this sequence is arithmetic. If yes, find the common difference. It's same kind of problem. We're doing exactly the same thing. We have 1.25, 2.48, so on and so forth. So we got to start by 2.48 minus 1.25. That's 1.23, right, is what you would add on. Okay. Do we just keep adding 1.23 on each time? 2.71 minus 2.48. 3, 4, 2. I think here I see right away that no, we're not, we're only adding 0.23 on, right? We're not adding 1.23 like we did. So there is not a common difference. This sequence is not arithmetic. That's all we got to say here. And we don't have any way to come up with a formula for this, since we don't know what's exactly what the pattern might be. So as soon as we decide it's not arithmetic, that we're not adding the same quantity on each time, we can just go ahead and stop. All right. And okay, I think I'm going to stop this video here, and we're going to do the remaining exercises in a separate video.